Now for this problem here, let's see if we can take some of the principles we talked about in the previous video about testing numbers and apply them to this absolute value problem here. So this question says, is the absolute value of a plus 2 greater than the absolute value of b minus 3? And so you can see here we have two variables and we have two absolute value expressions. And so this sort of falls under that second category of more complicated absolute value questions, which means it might be a good candidate for testing numbers. Now, one thing I want to preface this problem by saying is that doesn't mean testing numbers is the only way to do this problem. You might see a way to do this algebraically, or you might just sort of see a way in your head to do this. You don't necessarily want to think of, for any problem on the GMAT, that there's a single optimal way of doing it, and that is the only way of doing it. However, if you can do things both ways, both algebraically and by testing numbers, then you can decide which way works for you. And so for this problem here, I'm not saying testing numbers is the only way to do it. I'm more so just sort of pretending that I have decided I'm going to do this by testing numbers, because the one thing you don't want to do is spend 5 minutes deciding between how you should approach the problem. You want to just commit early on to one way, and then you can move at a very deliberate pace. So let's say we decided we're going to try and crack this by testing numbers. And so we said when we're testing numbers, we're designing an experiment, which means we want to be very organized. We want to make sure we are keeping in mind the criteria for answering our question. So statement 1 says, b is less than negative a. So what does that mean we're going to need? We are testing our numbers. We're going to need a. Really, we need a negative a, but we can get an a and use that to generate our negative a. So we need an a, we need a b, and from our a we can get a negative a. Then we need to answer our question. Is the absolute value of a plus 2 greater than the absolute value of b minus 3? And this here really is our criteria. This is where we're going to put either a yes or a no. And so I always put the question marks here so I know this is our hypothesis. We're either accepting or rejecting. So here, one thing we do have to keep in mind is we still have to fit the criteria given to us by a statement. So we have to make sure that our negative a is in fact greater than b. So for our first choice that we choose when we are testing numbers, I said choose anything. Choose the easiest number that comes to mind. So say, I'm going to say a is equal to 2, which means negative a is going to be equal to negative 2. And then you probably want to set it up similar to how I did here, where your negative a is to the right of b, so it looks similar to your statement. Now I just need to come up with anything where b is less than negative a, so I'll just say b is negative 3. This fits the statement, therefore this should be one possibility. Now I just need to see if it gives me a yes or a no to my question. And so a plus 2, so absolute value of a plus 2, so this will be 4. Absolute value of b minus 3, I shouldn't say this yet, negative 3 minus 3, so 6. In fact, we have this, so 6 is greater than 4, therefore this is a no to our question. And so now for our second choice, we said this is the choice that matters, because we are always trying to prove insufficiency, so now we should actively be trying to get a yes. And so if you're actively trying to get a different outcome than the first result, you might say, well, what's the easiest number I can choose that will get me a different outcome? And you might say something like negative 2. But remember, you can do this, but you are most likely going to get another no, because if you just look here at your criteria, what's going to happen? We now want a case where this side here, the left side, is going to be greater than the right side. If I choose -2, well, this side here, -2 plus 2 is 0. And so this is, in fact, the smallest possibility that we can have here. And so -2 is probably not a good option to choose. In fact, instead, I'll say, how about -20? So here I'm still I'm flipping the sign here, but I'm still going to get a large number on this left side, because when I take the absolute value of -20 plus 2, it's going to give me a large positive value. So if a is -20, negative a is positive 20. I want to make this side as small as possible. So I'll just say b is 4. How about? And then here, so absolute value of a plus 2. First of all, we fit our criteria, right? B is less than -a, so this should work. Then absolute value of a plus 2 is absolute value of -20 plus 2, which is absolute value of -18, which is just positive 18. Here, absolute value of 4 minus 3 is just 1. So here, we get what we want. Here we have a no. Then for our second choice, we have a yes. And therefore, we have proven insufficiency. And we can say A and D are out. So remember, if this first statement had been sufficient, you wouldn't really be able to prove it. But just for every option that you chose, you would just keep getting no's to your for your answer. Therefore, you would have to say, well, that's good enough for me to say this is sufficient. But you would not necessarily be 100% positive. So now let's look at our second statement. And our second statement maybe is one we should have started here, because second statement just says b is less than 0, tells us nothing about a. That's an easy elimination. And we can go straight to C, straight to looking at our answer choices together. And so remember from our last video, we said the one reason you want to be organized when testing numbers is so that you can reuse information from your first statement when looking at the second statement, or when looking at them together. By the time you look at them together, your head will probably be spinning, so you do not want to have to start from scratch. And so these are our choices from our first statement. If we combine that with our second statement, now we just need to make sure b is less than 0. And so it looks like our first choice here fits that. Our second choice here does not. 4 is not less than 0. Therefore, we cannot reuse this, but we can reuse this first option. So when we're looking at them together, we are starting with a no. So now I just need to make sure, come up with an example where b is less than 0. So I'm thinking, well, maybe what if I use this as the same example here for a, because I don't need to change anything about a. So say a is -20 and negative a is positive 20. Now here, b, I just need to make sure b is negative. And I'm trying to get a yes here, so I'm trying to get a smaller value on my right side. So I'll just say a is -1. Now, this should fit. This fits both categories. B is still less than -a. B is also less than 0. Therefore, let's see what this gives us. So -20 plus 2. So this gives us it's -18. Absolute value of -18 is just positive 18. Then b minus 3. So this should just be 4. And we get what we want. 18 is greater than 4. Therefore, we have our yes. Therefore, we have our no and our yes. Therefore, even together, our statements are insufficient. And we have proven that. Because you can prove insufficiency when testing numbers. You just can't prove sufficiency necessarily. So here our answer is E. Next, we will do another testing numbers absolute value question.